Good evening. Excitement is growing among planetary scientists and amateur astronomers as we wait to see the first ever close-up images of Pluto at the edge of the solar system. Later this month, the mystery of Pluto and its 5 known moons will be historically unveiled by the NASA New Horizons spacecraft. New Horizons was launched on January the 19th, 2006 from Cape Canaveral directly into an Earth and Sun escape path with an Earth relative speed of about 16 kilometers a second. It set the record for the highest launch speed of a man-made object from Earth. New Horizons travelled to Jupiter, making its closest approach on the 28th of February 2007 at a distance of 2.3 million kilometres. The Jupiter flyby provided a gravity assist that increased New Horizons' speed by about 4 kilometres a second, somewhere in the region of 14,000 kilometres an hour. The encounter was also used as a general test of New Horizons' scientific capabilities. Most of the post-Jupiter voyage was spent in hibernation to preserve onboard systems except for brief yearly checkouts. On the 6th of December 2014, New Horizons was brought back online and the instruments were checked and found to be working perfectly. On the 15th of January 2015, the New Horizons spacecraft began its final approach to Pluto. Here is a guide to the spacecraft and the instruments on board. This is New Horizons. The spacecraft is the same size and general shape of a grand piano. It is carrying a special passenger on board, the ashes of American astronomer Clyde Tombaugh, who discovered Pluto 85 years ago. The spacecraft's body forms a triangle which is almost 0.76 meters thick. The 2-meter radio dish antenna is fixed to the front, flat side surface of New Horizons. Titanium provides strength and thermal insulation. The rest of the triangle is primarily sandwich panels of thin aluminium less than half a centimeter thick, bonded to an aluminium honeycomb core. The structure is larger than necessary with empty space inside to act as shielding for the spacecraft. New Horizons has 4 science experiments on board, including LORRI, LORRI, the Long-Range Reconnaissance Image Camera. It has a focal length designed for high resolution and response at visible wavelengths. The instrument is equipped with a high-definition CCD imager with a lens over 20 centimeters in diameter. RALPH is a telescope and color camera. The RALPH telescope is 6 centimeters in aperture and is one of the 2 photographic instruments that make up New Horizons. RALPH has 2 separate channels, a visible light imager with broadband and color channels, and a near-infrared imaging spectrometer, while ALICE is an ultraviolet imaging spectrometer that makes up one of 2 photographic instruments comprising New Horizons Pluto Exploration Remote Sensing Investigation, or PSI. It resolves 1024 wavelength bands in the far and extreme over 32 view fields. Its goal is to determine the composition of Pluto's atmosphere. The radio science experiment, REX, will use an ultra-stable crystal oscillator and some additional electronics to conduct radio science investigations using the communications channels of the main radio dish. There is SWAP, Solar Wind at Pluto Electronic Analyzer. And finally we have SDC, the Student Dust Counter. The Student Dust Counter was built by students at the University of Colorado Boulder and will operate continuously throughout the flight path to make dust measurements. It consists of a detector panel about 18.5 by 12 centimeters in size, mounted on the night-facing side of the spacecraft with an electronic box inside the spacecraft itself. This is a truly historic occasion, and what we're about to see in the first close-up images of Pluto may surprise all of us. Travelling at a speed of 14 kilometers a second, New Horizons is intended to pass within 12,000 kilometers of Pluto on the 14th of July. These images show Pluto in the latest series of New Horizons long-range reconnaissance photos taken between May the 8th to the 12th, 2015, compared to images taken 1 month earlier. In the month between these images, New Horizons' distance to Pluto decreased from 110 to 75 million kilometers, as the spacecraft speeds towards a close encounter with Pluto. The April images are shown here on the left, with the May images on the right. Between April and May, Pluto appears to get larger as the spacecraft gets closer, with Pluto's apparent size increasing by about 50%. A day on Pluto is 6.4 Earth days long, and these images show the variations in Pluto's surface features during its rotation. The discovery of Pluto 85 years ago seems so far away now, while its reclassification to a dwarf planet by so few members of the International Astronomical Union, in my opinion, was an injustice. I will always regard Pluto as a planet. Clyde Tombaugh was actually born on a farm near Streator, Illinois, on the 4th of February 1906, and was the youngest of 6 children. He had a good upbringing and soon took an interest in the stars visible most clear evenings. In 1922, the family moved to a farm near Barnett, Kansas, where he went to grade school. Uncle Lee, who was an amateur astronomer, lived on a farm nearby where Clyde often visited at weekends. He was equipped with a 75mm refractor telescope, which was not of good quality since it showed spurious colour around the moon and planets. However, it proved to be useful to Tombaugh, who used it to study the night sky and learned his way around the constellations. In 1925, Clyde Tombaugh graduated from the small high school in Barnett, Kansas, and there was no prospect of him going on to college because times were hard. However, his interest in astronomy was enhanced enough for Clyde to have a go at constructing his own telescope, and in 1926 he set up a grindstone on a sturdy post and began to grind his own 20cm mirror. Upon completion, he sent it off to a French company for silvering while he built the telescope tube and equatorial mounting. When the mirror was returned, the French company, Napoleon Courroux, advised that it was not of good quality. However, with its maximum power of 84, it was sufficient to show some of the deep sky objects along with detail on most of the main planets, except Mars. Clyde was disappointed that he was unable to see any of the markings on Mars during the planet's opposition in November 1926. He therefore determined to build a much better 17.5cm reflector for his Uncle Lee, and Tombaugh learned from his mistakes. Upon completion, he had a pleasing view of Comet Ponsonby, which passed within 3,000 kilometers of the Earth in June 1927. This comet is believed to be the parent body of a June Boötide meteor shower occurring roughly between the 26th of June and the 2nd of July each year. With the money his Uncle Lee gave him for his telescope, Clyde Tombaugh began constructing yet another, which was a 22.5cm reflector. He soon put the telescope to good use, making astronomical drawings of the moon and planets, which proved to be a turning point in his career. Previously, the Lowell Observatory in Flagstaff, Arizona, had been established in 1894, placing it amongst the oldest observatories in the United States. The observatory's original 60-centimeter Alvin Clark telescope is still in use today for public education. The observatory was founded by astronomer Percival Lowell of Boston's well-known Lowell family, and is overseen by a sole trustee, a position historically handed down through the family. Percival Lowell used the Alvin Clark refractor to study the planet Mars and made numerous drawings of the planet's system of what he termed Martian channels. For 15 years, Percival Lowell studied Mars extensively and made intricate drawings of the surface markings as he perceived them. While this idea excited the public, the astronomical community was skeptical. Many astronomers could not see these markings, and few believed they were as extensive as Lowell claimed. As a result, Lowell and his observatory were largely excluded by the astronomical community. In 1909, the 1.6-meter Mount Wilson Observatory telescope in Southern California allowed closer observations of the structures Lowell had interpreted as canals, and revealed irregular geological features. Another telescope at the observatory is the 32.5-centimeter Cassegrain telescope, which was a new addition to the observatory in February 1929. It so happened that the observatory's director, Dr. Vesto Slipher, was looking for a suitable amateur astronomer to work with this newly acquired telescope. Clyde Tombaugh responded by sending in his drawings of Mars and Jupiter with a covering letter. After further correspondence, Dr. Slipher invited Clyde Tombaugh to Flagstaff for a few months' trial beginning in mid-January 1929. Previously, the prestige of the Lowell Observatory had been damaged by Percival Lowell's obsession with the Martian canals. Another hobby of his that interested him, that of discovering a trans-Neptune planet, which he referred to as Planet X, was brought forward. John Couch Adams, who was a British amateur astronomer and mathematician born in Lidcott in Cornwall in 1819, had carefully worked out the position of the planet Neptune a few months before its actual discovery, using a similar prediction by Urban Leverrier. Telescopic observations at the New Berlin Observatory confirmed the existence of a major planet, which was made on the night of September the 23rd to 24th, 1846. Not long afterwards, John Couch Adams was given equal recognition for the discovery of Neptune. As observations of Neptune began to accumulate, Lowell's greatest contribution to planetary studies came during the last decade of his life, which he devoted to the search for Planet X, a hypothetical planet beyond Neptune. Lowell believed that the planets Uranus and Neptune were displaced from their predicted positions by the gravity of the unseen planet. Lowell's search had begun in 1905 using a special 12.5-centimeter telescope, which was specially mounted to allow 3-hour time exposures to be made onto large glass photographic plates, which he carefully examined using an instrument called a blink microscope comparator. The blink comparator allowed Percival Lowell to place two plates side by side, and a mechanism allowed a mirror to flip, so that one then the other plate could be observed, one after the other. If Planet X was in the field, the star-like object would appear to hop between positions. Sadly, there had been no success for Percival Lowell until his death in November 1916, or during subsequent searches until the winter of 1928. Soon after his arrival at the Lowell Observatory, Dr. Slipher put Clyde Tombaugh to work using the 32.5 centimetre Cassegrain telescope to search for Planet X. Plate number 1 was taken on the night of April 6, 1929. Hundreds of plates were taken as Clyde worked his way along the plane of the ecliptic until they came to the region of sky containing the magnitude plus 3.3 star Delta Gemini, or WASAT to give it its proper name. The star lies close to the Milky Way, so that each photographic plate contained thousands of stars, and even recording each image proved troublesome. Clyde Tombaugh had to make 4 plates, each of which recorded Pluto. However, he did not know this until 10 months later. On the 23rd of January 1930, Clyde Tombaugh photographed the Delta Gemini region again, and took a further plate on the night of the 29th of January. On the morning of 18th of February, Clyde placed both plates on the blink comparator and was fortunate to start looking for Planet X on the eastern half. By around 4 p.m, Tombaugh had covered about a fourth of the plate when he suddenly seen a magnitude plus 15 star popping out and disappearing in the alternative views. Over the next 45 minutes, Clyde Tombaugh carefully checked everything to make sure there was no mistake. Clyde later recalled, "A terrific thrill came over me. Then he walked down the hall to Dr. Vesta Slipher's office, trying to control himself. He explained, I stepped into his office as nonchalantly as possible. He looked up from his desk. 'Dr. Slipher, I have found your Planet X.' He rose right up from his chair with an expression on his face of both elation and reservation. The two men immediately hurried down the hall to the blink comparator room, and Clyde showed Dr. Slipher the evidence. 'It looks pretty good to me,' he said. It was from this point a new addition to the solar system came to the attention of the astronomical world. The name Pluto, after the god of the underworld, was proposed by Venetia Barney, an 11-year-old schoolgirl who lived in Oxford, here in the UK.
Yes, I don't quite know why I suggest. I think it was on March the 14th, 1930, and I was having breakfast with my mother and my grandfather, and my grandfather read out at breakfast with my mother and my grandfather, and my grandfather read out at breakfast the great news and said he wondered what it would be called. And for some reason, I, after a short pause, said, why not call it Pluto? I did know, I was fairly familiar with Greek and Roman legends from various children's books that I'd read, and of course I did know about the solar system and the names the other planets have. And so I suppose I just thought that this was a name that hadn't been used. And there it was. The rest was entirely my grandfather's work. He was retired, but he had been Bodlei's librarian, which means the head librarian in the Bodleian at Oxford, which is the university library, of course. Professor Turner had been Astronomer Royal in the past, and was a professor at Oxford. On the day it was suggested, my grandfather dropped a note to him. He was, on that day, attending a meeting in London of the Royal Astronomical Society. They were all thinking about names, but for some reason none of them thought of Pluto. I just thought it was a name that hadn't been used so far, and might be an obvious one to have. Well, not to a limited extent. I think the newspapers were mostly occupied by the exploits of the woman pilot, Amy Johnson, at the time. Anyway, there was a certain amount in a few papers, I think. My grandfather collected any information there was through a press agency and put it into 2 scrapbooks that I have, which I treasure, and from which I can refresh my memory at times.
Pluto is a mysterious world. It lies at a distance of 5.9 billion kilometers from the Sun and takes 248 Earth years to travel once around its orbital path. Its orbit is remarkable. When at perihelion, Pluto is actually closer into the Sun than Neptune can ever be. It will next be at perihelion on the 15th of September 2237, when it will be 257 million kilometers closer to us than it is today. Pluto was moving inside Neptune's orbit between the 21st of January 1979 and March the 14th, 1999, so that it is now very remote. Pluto will be at aphelion, its most distant position from the Sun, on the 19th of February 2114. As the planets move around the Sun, their orbits are inclined to the plane of the ecliptic. Astronomers call this inclination. Most of the planets move in about the same orbital plane, with inclinations ranging from 3 degrees for Venus and less than 2 degrees for Mars, Jupiter, Saturn, Uranus and Neptune, while Mercury has an inclination of 7 degrees, which is greater than its planetary neighbours. Pluto, however, is exceptional. It has an inclination of 17 degrees, which makes it stand out from the rest. The diameter of Pluto has been difficult to determine because the planet is so remote. At the moment, our best estimate is 2,390 kilometers, making it almost 1,086 kilometers larger than our own moon. Back in 1936, astronomers did not have the powerful telescopes we have today, and were using various methods to work it out. The astronomer Andrew Cloyd Crommelin of Greenwich suggested the theory of specular reflection. If Pluto was highly reflective because it was covered with ice, the bright light of the Sun might falsify the diameter estimates so that Pluto could be much larger and more massive than it seemed. Also in 1936, astronomer Raymond Littleton of Cambridge suggested that the planet Pluto might be an escaped satellite of Neptune. The largest moon of Neptune is Triton, which is 2,706 kilometers in diameter and is the only moon with a retrograde orbit. That is to say, it moves in the opposite direction to all the rest. So the idea of the disturbances in the remote past was logical. The first measurement of Pluto's diameter was made by astronomer Gerard Kuiper using the 2-meter reflector at the McDonald's Observatory in Texas in 1949. The diameter was given as 10,197 kilometers. The following year, Gerard Kuiper made new measurements with the Palomar 5-meter reflector, and the diameter was reduced to 5,792 kilometers, making Pluto smaller than Mars and Neptune's moon Triton. The diameter was further refined in 1965 when Pluto partially occulted a magnitude +15 star in the constellation of Gemini the Twins, which was observed using the 14.5 centimeter refractor at the Lick Observatory. The next problem for astronomers was to work out the rotation period of Pluto. The planet is so remote that its angular diameter is tiny, about 0.1 seconds of arc, so that observing any surface feature was an impossible task. The alternative was to carefully measure the planet's magnitude over time to see if there were a regular variation. In 1955, astronomers M. Walker and R. Hardy found that the brightness of Pluto varied by 20% in 6.39 days, which most astronomers today believe is due to the planet's rotation. This tells us that there are 14,100 Plutonian days in each Plutonian year. Of course, if Pluto happened to have a moon, observations of the motion of the satellite could be used to accurately work out the mass of Pluto. The planet had already partially eclipsed a star in 1965, and astronomers at the U.S. Naval Observatory in Arizona was busy taking photographs of the planet using the 24.5 centimeter reflector to predict future occultations. Nothing unusual showed up until astronomer James Christie took photographs of Pluto in April and May 1978. When he examined the plates on the 22nd of June, Pluto's image appeared to be elongated. He therefore rechecked the plates taken in previous years, and the same effect was seen. There was an air of excitement. Did Pluto have a satellite? Astronomer James Graham confirmed the discovery on the 6th of July 1978 using the 4-meter reflector of the Cerro Toledo Observatory in Chile. The moon has since been named Chiron. The Earth has one natural satellite, the Moon, which is 3,476 kilometers in diameter and orbits our planet once every 27 days. The diameter of the Earth is 12,756 kilometers, so that our planet is 3.5 times bigger than the Moon. Therefore, most astronomers prefer to consider the Earth-Moon system as a double planet, which is a unique arrangement, or so we believed, up until the discovery of Chiron. Chiron has been measured to be 1,200 kilometers in diameter and takes 6 days, 9 hours to orbit Pluto at a mean distance of 19,570 kilometers, so that Pluto is almost twice the size of Chiron, and the system can again best be described as a double planet. Also, as was the case with the Earth-Moon system, Chiron is locked in synchronous rotation with its parent planet. The atmosphere of Pluto was discovered in 1980. Its density is very low, with an atmospheric pressure of 100,000 times less than the Earth's at sea level. It is very extensive, at least as deep as the planet's diameter of 5,792 kilometers. The main constituent is thought to be methane, and there may be some carbon monoxide and even argon. Pluto is so remote from the Sun that it receives very little of the Sun's warmth, so that its surface temperature is around minus 220 degrees centigrade. When Pluto is in the far part of its orbit, as it will be in the year 2114, the temperature is so low that methane may be expected to be frozen out, so that it is possible that for part of the year Pluto has no atmosphere at all. The close approach of New Horizons to Pluto will take place on the 14th of July, and the instruments on board the spacecraft will study the atmosphere in detail. Here is a general guide as to what we can expect to happen on this historic occasion. Starting on 10th of July, long-range imaging will include the mapping of Pluto and Charon to 40-kilometer resolution. This is half the rotation period of the Pluto-Charon system and will allow imaging of all sides of both bodies. Coverage will repeat twice per day to search for changes due to snows or ice volcanism. Due to Pluto's tilt, a portion of the northern hemisphere will be in shadow at all times, and New Horizons will not be able to image the area. On the 14th of July, beginning at 11 o'clock UT, New Horizons will begin its close encounter of Pluto and its moons. The spacecraft is intended to pass within 12,000 kilometers of Pluto at 11:50 UT, when it will have a relative velocity of almost 14 kilometers a second and will come as close as 27,000 kilometers to Chiron, Pluto's largest moon. During the flyby, the instrument LORRI should be able to obtain images with a resolution as high as 50 meters per pixel and should obtain 4-color global dayside maps at 1.6 kilometer resolution. The cameras on New Horizons will attempt to overlap their respective coverage areas to form stereo pairs. At 1300 hours UT, New Horizons will pass behind Pluto. This is when the radio science experiment begins. Radio signals from the high-gain antenna will pass through the different layers of Pluto's atmosphere, which will give planetary scientists a better understanding of its true size and composition. While the close encounter phase ends at 1500 UT, all the instruments on board New Horizons will continue to study Pluto and its system of moons as the planet recedes into the distance. The Hubble Space Telescope was launched into orbit on the 24th of April 1990. It has a 2.4 meter mirror and is ideally placed to make observations above the Earth's atmosphere. 2 additional moons were imaged by astronomers working with the Hubble Space Telescope on the 15th of May 2005. The International Astronomical Union officially named Pluto's newest moons Nix, the inner of the two, and Hydra, the outermost moon, on the 21st of June 2006. These small moons orbit Pluto at approximately 2 and 3 times the distance of Chiron, Nix at 12,600 kilometers and Hydra at 12,614 kilometers. They have nearly circular orbits in the same orbital plane as Chiron. As I explained earlier, astronomer Andrew Cloyd Cromlin of Greenwich suggested the theory of specular reflection, and this is the main difficulty when it comes to trying to measure the diameter of these 2 new satellites of Pluto. If Nix and Hydra were highly reflective because they are covered with ice, the bright light of the sun might falsify the diameter estimates, so that the moons could be much larger and more massive than they seemed. Albedo, from the Latin albedo, which means whiteness, is the diffused reflectivity or reflecting power of a surface. Hydra is sometimes brighter than Nix, suggesting that it is larger or that different parts of its surface may vary in brightness. Their sizes are estimated from their albedo. If their albedo is similar to that of Chiron, which is 0.35, then their diameters are 120 kilometers for Nix and 157 kilometers for Hydra. A 4th moon, Kiberos, was announced on the 20th of July 2011. It was detected using NASA's Hubble Space Telescope during a survey just searching for rings around Pluto. It has an estimated diameter of 32 kilometers and is located between the orbits of Nix and Hydra. Kiberos was first seen in a photo taken with Hubble's Wide Field camera on the 28th of June 2011. It was confirmed in subsequent Hubble pictures taken on the 3rd of July and the 18th of July. A 5th moon, Styx, was announced on the 7th of July 2012 while looking for potential hazards for NASA's New Horizons spacecraft. Styx is believed to have a diameter of between 34 and 65 kilometers and to orbit Pluto at a distance between Chiron and Nix. A few weeks ago, NASA held a news conference to release new findings discovered by the Hubble Space Telescope that showed two of Pluto's moons, Nix and Hydra, wobble unpredictably. The moons wobble because they're embedded in a gravitational field that shifts constantly. This shift is created by the double planet system of Pluto and Chiron as they whirl about each other. Pluto and Chiron are called a double planet because they share a common centre of gravity located in the space between the two bodies. Their variable gravitational field sends the smaller moons tumbling erratically. The effect is strengthened by the rugby ball-like rather than spherical shape of the moons. Scientists believe it's likely Pluto's other two moons, Kiberos and Styx, are in a similar situation. The astonishing results were found by Mark Showalter of the Satai Institute in Mountain View, California, and Doug Hamilton of the University of Maryland at College Park. Some astronomers now believe that Pluto's moons were likely formed by a collision between Pluto and a similar-sized body early in the history of our solar system. The collision flung material that consolidated into the family of moons observed around Pluto we see today. The discovery of Pluto begins with its discovery by American astronomer Clyde Tombaugh in 1930. And it concludes this month with the arrival of New Horizons at the planet Pluto, carrying the ashes of Clyde on this truly historic occasion. That is all we have time for this month. Please visit our website, Vimeo, where you can find all of the past shows of astronomy and space. And if you like this program, please share it with your friends and members of your local astronomical society. Until we come back next month, good evening.